Today our topic of discussion is circles. Okay. In this chapter we will discuss about the tangent to a circle. The next topic will be angle between the tangent and chord, and the third one is the common tangents. So in this chapter of circles we will emphasize on this topic only. Okay. So first topic is the tangent to a circle. Which one is the tangent to a circle? This is a circle. You must remember, when a line touches the circle just only one point, this is called the tangent. So this is a circle with center O, and AB is a line which touches the circle just only one point P. So AB is tangent to that circle. If we draw the circle with center O and the line AB in that way, is it a circle? Is it a tangent to the circle? It touches the circle in 2 points. You can see that it touches the circle in 2 points. So this is not a tangent to the circle. Always tangent touches the circle just only one point. Okay. Here you see that the first property of tangent we have to prove that tangent to a circle is always perpendicular to the radius at the point of contact. What does it mean? That means if we draw the circle with center O, so the theorem, this property tells us that at the point of contact P, the radius OP, here the tangent AB is perpendicular to that radius. Okay, that at the point of contact, which is the radius of the tangent is the perpendicular to that radius. That means we have to prove here AB is perpendicular to OP. AB is perpendicular to OP. But we assume first that this is not true. So we assume no, AB is not perpendicular to OP. Okay? And we take another point Q here. Okay? And we join OQ. And we will assume that AB is perpendicular to OQ. We assume AB is perpendicular to OQ. We assume it. Okay? And as we know that the perpendicular distance is the shortest distance, so we assume that OP is greater than OQ. Because OQ is perpendicular, so OQ is shorter than OP. Okay? But here you see that the line AB touches the point P as usual as Q also. Okay? But what we know about tangent? The tangent line is a line which touches the circle only at one point. As it touches the circle at the point P, so Q must be exterior point. Okay, Q cannot be on the circle. Q must be a exterior point. So Q is exterior point. So the line OQ will touch one point on the circle. Let it be R. Okay. As Q exterior point, so the line OQ touches the circle at the point R. But here you see that OP and OR are the radius of the circle. Both are the radius of the circle. So OP and OR will be equal radius of circle. Okay. So here you see that R is a point between OQ and OP and OR equal. So OR must be less than OQ. R is a point between OQ and so OR is less than OQ. So we can say that OP is less than OQ. OP is less than OQ. But how it will be possible? Because we have assumed that OQ is the shortest distance as OQ is perpendicular to AB. So our assumption was wrong. So we can say that our assumption is that AB is perpendicular to OQ is not true. So AB is perpendicular to OP. Now here we discuss about the property related to two tangents drawn from outside of the circle. Here you see that here our given circle is this with center O and the point outside of the circle is P. From the point P, two tangents are drawn to the circle. One is PA, one is PB. Okay. So this property we have to prove here. Okay. First of all, AOP is equal to BOP. That means angle AOP, this angle, and angle BOP, this angle are equal. We have to prove it. The next one, angle APO and angle BPO are equal. That angle APO, that means this angle, and angle BPO, that means BPO, that means this angle. That means this angle are equal. We have to prove it. The next one, angle AOB plus angle APB is 180 degree. Angle AOB, that means this full angle, and angle APB, that means this full angle. The summation of this is 180 degree. And next one is AP and BP are equal. So the tangents, if two tangents are drawn from outside of a circle from a point, so we have to prove these properties satisfied. Okay. So here you see that first of all that PA and PB are tangents and the radius of this circle at the point of contact A and B are one is AO and one is BO. Okay. So what we have already proved that the tangents is perpendicular to the radius at the point of contact. Okay. So here this angle, this is a perpendicular and this is also a perpendicular. This makes the tangent with the radius at point of contact, and this also makes the angle, this tangent makes the angle with the radius at the point of contact. So these two angles are 90 degree. Okay. So we consider two triangles here. One is AOP and another is BOP. For these two triangles, this angle are equal. So OAP Okay, and OA and OB are equal. OA and OB are equal. Why equal? Because they both are radius of same circle. So radius. This is radius. Okay, and so we can say OAP and OBP both are right angle triangle, and OAOP is the hypotenuse both of these right angle. So OP is common. Okay, for both the triangle OP side is common. So we can say that the triangle AOP is congruent to triangle BOP. Okay, two sides are equal and in one angle is equal. So these two triangle is congruent. So from here we can say that as first of all AOP as this angle and this angle are equal. Okay, so from here we can say AOP and BOP equal, and for the here also angle number 2, angle APO, angle BPO are equal. Okay, and now you see that the summation of these two angles are 90 degree. As for the triangle AOP, this is 90 degree. So this AOP and APO are 90 degree. So angle AOP and angle AOP and angle APO 90 degree. Okay, for the triangle AOP, this angle and this angle, summation of these two are 90 degree. These are 90 degree. And for the triangle BOP, this triangle, this is 90 degree. So this summation of these two also 90 degree. So this equal to BOP plus BPO. Okay, we can write it. So here we can say that angle, if we add both of these, so angle AOP plus angle BOP, we add these two, and here we add APO plus BPO. We just add both of these. This is also 90 degree. So we add these two. So here we can say this angle AOP and angle BOP. If we add this, we can get AOB. And angle APO and angle BPO, if we add this, we can get angle APB. So these are 90 plus 90, 180 degree. Okay. And for the congruence of both of these triangles, we can say AP is equal to B. Okay.